Welcome to Math with Mrs. Bibb. Today we will be solving systems of equations by graphing, substitution, and elimination. A system of equations is a set of two or more equations with the same variables. The solution is where the graphs intersect and written as an ordered pair, x, y. There are three ways to solve a system of equations: by graphing, either by hand or using Desmos. We're going to use Desmos, substitution, or elimination. And if you need to pause to write down those definitions, please do pause and then carry on to the next page. To save time for me, I went ahead and filled in this chart, but I want to go over this with you. You have three systems of equations here. For this first system of equations, the type of graph that it is, it's two lines that intersect at one point. The equations have different slopes and y-intercepts. The solution or solutions to this system is one solution at the point of intersection x, y. And then when you're asked to classify these types of solutions, these solutions, or this solution specifically, is consistent and independent. So when it has solutions, it's consistent, and when it has one solution, it's independent. So consistent and independent. For the second one here, this one here, this is the type of graph that it is two lines that overlap. So this is actually two lines, and those equations have the same slope and y-intercept. The solutions to this is infinitely many solutions because that graph intersects, those two graphs intersect in an infinite amount of places. And then because it has solutions, it's consistent and it's dependent. These two lines are dependent upon one another. So consistent and dependent. Then the last graph here, this graph is a type of graph that has two lines that are parallel. The equations have the same slope but different y-intercepts. And since they do not intersect, the answer is no solution. And since there's no solution, it is an inconsistent system. So if you need to pause to write that down, please do. But hopefully you listen to those explanations. For this first set of systems of equations, it says determine the number of solutions of each system and then classify the system correctly, meaning consistent, independent, so on and so forth. Now we're going to use Desmos. I have it up here. If you would like, you're welcome to open Desmos and graph at the same time that I do, so that you can see what this looks like, because it's definitely not very big. I'm going to type in the first equation, y equals negative 2x, negative 2x plus 14. And then I'm going to type in the second equation, 3/5 x, 3 divided by 5, x plus 1. And it looks like the number of solutions this graph has, let's write that down. This graph has one solution. And according to the chart on the previous page, since it has one solution, it's consistent and dependent. And then that one solution is, let me go back and click on the screen. Looks like 5, 4. That is the solution, 5, 4. And that answers all the questions there for the first one. Let's do the second one. I'm going to type in negative 3x, negative 3x plus 2y equals 12. And did I get 12? No. Equals 12. And 6x minus 4y equals 8. Okay, it looks like those two lines are parallel. They're never going to intersect. So that means that there are no solutions. It's inconsistent. And again, where we wrote by 4, this one is no solution. That's number 2. Number 3, oh, gotta go back and get the pointer. It'll take me a second. It always takes me a second to go back. Okay, I'm sorry about that. Okay, it's letting me move. There we go. No. Mm-hmm. Well, I collapsed where you put in the equations. You could probably put yours in and be finished before I even get done. Come on, please. Does that work for you all? To ask nicely? There we go. I don't really know what I did, but there we go. Okay, y equals 2x plus 1 let me erase right there. And then in the second one, 4x minus 2y equals negative 2. Now that looks like it is also no solution. Did I type it in correctly? Oh, I'm erasing what was up there, but that's okay. We've already done that and written it down. Y equals 2x plus 1. 4x minus 2y equals negative 2. So that's where I messed up. Negative 2. And look, it looks like the same line. Here's what I do to test that. If you click in the circle, like I clicked in the circle where there was a 2, it took away the blue line and the red line is there. If I click back in that circle again, then that red line turns blue. Watch, it's red, now it's blue. It's red, now it's blue. So this one is infinitely many solutions. And this would be consistent and dependent. Oops, consistent and dependent. And again, the answer is no, infinitely many solutions. Okay, going on to the next one. Steps for solving a system using substitution. So step 1, if not done so already, solve one of the equations for one of the variables. Step 2, substitute the resulting expression from step 1 into the other equation, then solve. Step 3, substitute the value for step 2 into either equation, solve. Write the solution as an ordered pair. If you need to, go ahead and pause the video so that you can write down the steps there. And then I'm going to go on to to the first example under solving the systems using substitution. So for number 1, determine the number of solutions for each system, classify the system correctly, then solve using substitution. And I kind of do that backwards. I'm going to solve using substitution, then do the rest of that stuff. So the steps that we wrote on the previous page was, if not done so already, isolate one of the variables. And if you look at mine, I already have y and x isolated. So I'm just going to choose the top one. Y is already alone, so I'm going to take this expression, negative 2x plus 14, and substitute it in for y in the next equation. So I would have negative 2x plus 14 equals 3/5 x plus 1. Now I want to get rid of this 5 as a fraction, so I'm going to multiply everything by 5 to get rid of it. That'll help us out. So negative 10x plus 70 equals 3x plus 5. I'm going to subtract 3x, so negative 13x plus 70 equals 5. Subtract 70. Negative 13x equals negative 65. Divide by negative 13. X will equal positive 5. So positive 5 is my x value. Now to find my y value, I'm going to put it into that top equation. Y equals negative 2 times 5 plus 14. So y would equal negative 10 plus 14. Y will equal, it looks like, 4. So negative 5, positive 4 is the solution to that first system using substitution. Now, when I look at the next one, I do not have a variable alone. This has negative 3, this has 2 with it, this has 6, and this has 4. I think what I will do is solve the bottom equation for y. So I think I'm going to get this y alone. It really doesn't matter. We could have solved this top one for x. But I think I'm going to solve the bottom one for y. I am going to subtract 6x from both sides. So negative 4y will equal negative 6x plus 8. Then I'm going to divide by negative 4. So y will equal positive 3 over 2x minus 2. Then I'm going to substitute this expression in for y. So I'm going to put it into the y. Negative 3x plus 2 times 3/2 x minus 2 equals 12. Negative 3x plus 3x minus 4 equals 12. This becomes 0. So I have negative 4 equals 12. This is one of those special solutions. Remember, when your variable cancels out and you have a true statement, it's infinitely many solutions. And when you have a false statement, then it's no solution, which reminds me of something. So this is no solution, and then this one is inconsistent. To go back to number 1. For number 1, we have one solution. So there's one solution. And to define that system or classify it, that would be consistent and independent. And that one solution is 5, 4. Now let me solve the last one using substitution. I will take this expression and put it in for y. Since I already have one of the variables alone, I'll take that expression, put it in for y. 4x minus 2 times 2x plus 1 equals negative 2. 4x minus 4x plus 2 equals negative 2. Oh, I just made a mistake. This should be minus 2. 4x minus 4x minus 2, whoops, now it's 22, oopsie, minus 2 equals negative 2. I'm going to combine like terms here. That gives me 0. So I have negative 2 equals negative 2. This is a true statement. So I know my solutions are infinitely many solutions. And the system is consistent and dependent. And that's what we need, consistent and dependent. That's all the answers to those systems using Desmos. The next one, I believe, is elimination, the steps for that. So the steps for solving using elimination, you multiply one or both equations by a constant to get the coefficients of one variable the same but opposites. Step 2, add the equations eliminating one variable and then solve. And then step 3, substitute the value from step 2 into one of the equations and solve for the other variables. Write the solutions as an ordered pair. So there's my first example. I have 10x plus 5y equals 30, and I have 5x minus 3y equals negative 7. For step 1, you get to choose. You get to choose which variable you want to get alone. And I'm going to choose x on the first one and choose y on the second one. But you could choose y on the first one and x on the second one. So the first thing I'm going to do is look at the coefficients of x. I have 10 and I have 5. Some teachers tell students just to multiply 10 times 5 and use 50. I don't teach students to do that. I tell students to think. I've got 10 and I have 5. Multiples of 10, 10, 20, 30, 40, so on and so forth. Multiples of 5, 5, 10, 15, 20. You want to choose the multiple, the least common multiple that they have in common, and that is 10. So I'm going to multiply this equation here by 1 to keep that a 10. I'm going to multiply the bottom equation by 2 to turn that into a 10. And then the last thing I ask myself is, are these two coefficients opposites? Is one a positive and one a negative? And the answer to that question is no. So I usually make the smallest number a negative. And now I'm going to distribute. I'll have negative 10x plus, nope, I'll have minus 5y equals negative 30. And then I'll have 10x minus 6y equals negative 14. Add them together. Negative 11y will equal negative 44. Divide both sides by negative 11. Y will equal positive 4. Now I have half of my problem solved. I know that y is 4. I have to find the other answer and then determine the solutions. Well, I do know there's one solution since that worked out. And then to find the x value, you take this y value of 4 and you put it anywhere you see a y. I am going to substitute into the bottom equation because that y, all those numbers are smaller, at least I think they are. So I'm going to substitute 4n for y into the bottom equation. 5x minus 3 times 4 equals negative 7. I'm going to multiply 5x minus 12 equals negative 7. I'm going to add 12 to both sides. So 5x will equal 5. Divide by 5, x equals 1. So the solution is 1, 4. That's one solution. And then this is a consistent and independent system. Then for the next one, I'm going to solve for y. I am going to look at these coefficients, 4 and 3. Multiples of 4, 4, 12, 16, 20, 24. Multiples of 3, 3, 6, 9, 12. And there's the multiple they have in common. I am going to multiply the top equation by 3 to turn the 4 into a 12, and the bottom equation by 2. No, by 4 to turn that into a 12, sorry. And then I'm going to ask myself, are these two opposites of one another? And they are not, so I'm going to make one of these a negative, and I usually choose the smaller one. So I'm going to distribute negative 3 to all those numbers at the top. So that would be negative 9x minus 12y equals positive 66. Then I'm going to distribute the 4 to the bottom ones. Negative 8x plus 12y equals negative 32. Add them together, you get negative 17x equals 66 minus 32. That would be 434. Divide by negative 17. X would equal negative 2. So I know that this has one solution. And I'm going to substitute into the bottom equation negative 2x plus 3 times y equals negative 8. Negative 2 times negative 2 plus 3y equals negative 8. Positive 4 plus 3y equals negative 8. Subtract 4. 3y equals negative 12. Divide by 3. So y is going to equal negative 4. That's the other solution. And this is consistent and independent. Okay, moving on to the next slide. Solve using any algebraic method, and all I want is the solution. So if you will, let's do this. Let's do elimination for this one, and we'll check these in class, but I want you to try it yourself. Just try, even if you get part way and you don't get it done, that's fine. Don't Google it and find the answer and copy down the work. Try to do elimination for this one. Let's all eliminate x, and then try to do substitution with this one. And let's just go ahead and get our y by itself. So if you will try those 2 questions, and then you will be finished with this assignment. Have a wonderful day.